In this video, here is a question for the 10th standard CBSE mathematics on the topic polynomials. This is the question. If alpha and beta are the zeros of a given quadratic polynomial, f of x is equal to x squared plus x minus 2. Find the value of 1 by alpha minus 1 by beta. We are given alpha and beta are the zeros of the given quadratic polynomial, which is given as x squared plus x minus 2. We have to find the value of 1 by alpha minus 1 by beta. This is a fairly easy question, but here again it involves a certain amount of lateral thinking. Pause this video if you would like to give this problem a try. Read the question carefully and try to answer this question. Let us see the solution. The solution is this. Given that alpha and beta are the zeros of f of x equal to x squared plus x minus 2. It is required to find the value of 1 by alpha minus 1 by beta. The first step is to simplify the expression 1 by alpha minus 1 by beta as. The way we have to simplify this would rather be an easy process. First, we will try to simplify this way. Not a difficult thing at all. LCM of alpha and beta. The denominator, we can take it as alpha beta. So 1 by alpha minus 1 by beta is just beta minus alpha. It is multiplied by beta there. Beta by alpha minus beta by alpha beta. So beta minus alpha by alpha beta. Hope you understood this. Now we need to little bit simplify this because we don't require beta minus alpha. It's better if we have alpha minus beta with us. So we take out the minus sign, taking the minus sign outside and changing the sign within the brackets. Taking the minus sign out and changing the sign within the brackets, we get minus of alpha minus beta by alpha beta. As usual, we have the sum of the zeros alpha plus beta is equal to minus 1 by 1 minus the coefficient of x squared minus the coefficient of x by the coefficient of x squared, which is minus 1. Again, product of the zeros, alpha beta is equal to constant term by the coefficient of x squared, c by a, that is minus 2 here. You can verify that. But we have to find alpha minus beta to evaluate the required expression. CV, the required expression, what we need is 1 by alpha minus 1 by beta, which is actually simplified as minus of alpha minus beta by alpha beta. So in order to find alpha minus beta, we using the extended identity alpha minus beta the whole squared is equal to alpha plus beta the whole squared minus 4 alpha beta. In one of the previous videos also we saw this. A very helpful identity, this one. You can interchangeably use it for finding either alpha minus beta the whole squared or alpha plus beta the whole squared. Coming to this, So alpha minus beta the whole squared is equal to alpha plus beta the whole squared. Alpha plus beta is minus 1. So minus 1 the whole squared minus 4 alpha beta. So 4 times alpha beta, we already know it is minus 2. So 4 into minus 2. It becomes minus 1 the whole squared is 1. And minus into minus is plus. 4 2s are 8. So 8. 1 plus 8 is equal to 9, which is a perfect square. So alpha minus beta the whole squared is equal to 9. Alpha minus beta is equal to plus or minus root 9, which is equal to plus or minus 3. Now substituting the values of the alpha minus beta and alpha beta in the simplified expression, which is minus of alpha minus beta by alpha beta. We either use plus 3 or minus 3. We will be getting two values here. We may get, if you use 3, the positive value, positive root of alpha minus beta, you get minus 3 by minus 2. If you use the negative root, minus of minus becomes plus, plus 3 by minus 2. So we have two values. Either it is minus 3 by 2 or 3 by 2. You can have any one of these two values. This is the required value. The given expression, what we need is 1 by alpha minus 1 by beta evaluates to either minus 3 by 2 or 3 by 2, which is the required answer. In other words, we can also write it this way: plus or minus 3 by 2. So the value of 1 by alpha minus 1 by beta is plus or minus 3 by 2, and that's the answer. Thanks for watching.